but now it's going to be a weighted block model. We're going to have a term that represents edge existences. This is going to be the classic stochastic block model with the binomial distribution representing whether an edge exists or not, or what value we put on that tie. And then we're going to add to it another term which represents the value of the ties that exist. So here, this is our old friend. This is our mixing matrix, or our stochastic block matrix. This is our set of labels, our colors. But down here, we use the same colors, but now we have another matrix theta. And each element in theta is going to represent whatever numbers I need to parameterize the weight distribution for that set of edges, for that set of pairs. We're going to do it in a pretty general way. We're going to do it so that we can choose any exponential family distribution, which essentially covers all the ones people usually care about: normal, gamma, Poisson, exponential, Pareto, et cetera. So given that we have some graph G, our job now is to infer the labeling. So again, we want to find the right coloring of the graph such that the two matrices we get out of here, the mixing matrix for the edge existence and then the edge bundle parameters for the weights, end up maximizing either the posterior distribution of the graph, or posterior distribution of the parameters given the graph, or maximize the likelihood of the graph itself. We can do this using either two sort of sophisticated techniques for machine learning, and then we can use a technique to choose how many colors as well. So I'm not going to go into the details of how these methods work, mostly because I think the results are pretty exciting, and I want to focus on those. So given that we have this tool, let's now apply it to some data. And since we're in Colorado, we might as well apply it to some data that has Peyton Manning in it. Actually, Peyton Manning's not on our team in this season, which is sad. I don't have data on that year yet. Anyway, so NFL 2009 is 32 teams. It's a small network. That's why I chose it. Also because it has a subtlety embedded in it that I want to use to illustrate a point. So 32 teams, 2 divisions. Each division has some subdivisions. So edge existence in this graph is who plays whom.